Question 7. So we're using the formula that density is equal to mass divided by volume. We know the mass, we can find the volume, we're trying to find the density. So the volume is 8 times 10 times 5, which is 400 centimeters cubed. So then the density is 1.1 divided by 400. So the density is 2.75 times 10 to the power minus 3, and it's asking for units. Now the mass is measured in kilograms. We're dividing by centimeters cubed, so it is kilograms per centimeter cubed. Question 8, find the difference of the volumes. So it tells you the formulas. So for this one, it's L squared times H. So for the tin, the square based one, we have 18 squared times 10, so that is 3,240 centimeters cubed, because we're working in volume and it's asking for the units again. For the round tin, it tells us that it's pi r squared times h, so this is pi times by 12 squared times by 7, so that comes to 3166.73 centimeters cubed. And then obviously the difference, we're just going to take away the 3240, and we're going to take away the smaller one. So the difference is 73.27 centimeters cubed, again because we're talking about volume. Part B says they're made using the same tin. That means we're going to use the surface area formulas to show which one uses less metal. So the square one, the surface area formula is given to us, which is 4 times by the length times by the height plus 2 times the length squared. So that is 1,368 centimeters squared, because we're talking about an area. And then the round tin, 2 pi r squared h, 2 times pi times by r times by h plus 2 times pi times r squared, which is 12 squared again, and that comes to 1432. So which biscuit tin uses less? So the square biscuit tin uses slightly less, and it doesn't ask by how much, so we don't need to subtract them. Question number 9. The circumference of the circle is 26.7. Find the perimeter, and they tell us that this line and this line is the same. So using c equals pi times diameter, I can find the diameter of that circle. As I know, 26.7 divided by pi will be the diameter. So 26.7 divided by pi gives me 8.5 centimeters as the diameter of this circle. That tells me the diameter here is as well. I'm now going to use Pythagoras' theorem, so I know 8.5 centimeters squared is equal to, now as this is a square, I can call both these x, so it's x squared plus another x squared. That is saying that 8.5 squared is equal to 2 lots of x squared. I can take the 2 over and divide, so I get 8.5 squared divided by 2 equals x squared. So 8.5 squared, divide that by 2, so I find that 36.125 is x squared. Square root that answer, and I find that 6 centimeters is x, and then the perimeter of this would be, so the perimeter is just going to be 4 lots of that 6. So the perimeter is 24 centimeters. Question 10, percentage increase. I'm going to use new amount equals original amount times by multiplier to the power of years. So I'm trying to work this out. The original amount is 450. The multiplier is 1.052 because it's 100% plus the 5.2, so that's 105.2%, which when I turn back into decimal becomes this. He is going to be doing this over 4 years, so to the power of 4, and then I can simply type all of that into the calculator in one go, and I get £551.16. So the answer is yes, he can, as this is greater than the 550 he needs to spend. Part B, write 6.8 as a decimal, 0.068. AER is always going to be more expensive as it is interest over time, so it is being accumulated over time, so it will always be higher. If you're unsure about this question, if you find the AER in part III, you can go back and answer that at least later to decide which one it is. So using this formula, I have 1 plus the normal interest rate as a decimal, so that is 0.068, divided by the number of compounding periods per annum. So this says paid quarterly, so in a year that happens 4 times. To the power of 4, subtract 1. Be careful when you put this on your calculator, make sure you type it in correct and your calculator knows what it's calculating, so you have brackets in the correct place. If you follow the formula they give you correctly, you should be able to type that into your calculator exactly as it is, and that comes out as 0.0697. Now remember, this is as a decimal, so I need to times that by 100 to get 6.98% as a decimal. Explain why banks use AER. The reason for this is to compare different banks and to compare rates fairly. Question 11. We know the angle is 142. We know that there's 1.8 here and another 1.8 there. So the large sector, so the sector OBC, will be 142 divided by 360 times by pi times by, now the radius of this will be the full 3.6 squared. And that comes to, so the area of the whole sector, if I can do it on the calculator correct, so times pi times 3.6 squared, so the area of the whole sector is 16.059, a bit more centimetres squared. The smaller section, so if we have OAD, is still going to be 142 divided by 360, still times pi, but this time it's only times by 1.8 squared. So times pi times 1.8 squared, that comes to 4.0149 dot dot dot. They want to know the area, so I'm going to do the whole sector minus the bit inside. So then I get 16.059, take away 4.0149. So I find that the area is about 12.04 centimetres squared. Question 12, write down the gradient of the curve at 4.6. 4.6 is here. If I was to draw a tangent there, it would be a straight line, so the gradient is 0. Part B, find an estimate for the acceleration at time 3.5. Now acceleration is the gradient of the curve, so at the time 3.5 I'm going to draw a tangent the full length, and then I'm going to turn this into a triangle. I'm going to go from this point here because it's a nice round whole number I can use, and I'm going to go to here, which takes me to another whole number in both directions to make my calculation as easy as possible. Remember what I said in class about keeping the value at the bottom a whole number. So this is going from 1 up to 7, so we are dividing by 7, and then we are going 10, 15, 16, 17, we are going 18 up. So the calculation is 18 divided by 7, and 18 divided by 7 comes to 2.57 meters per second squared for acceleration. Yours might be slightly different because it's based on how your tangent is drawn. Next question then asks for the trapezium rule. So the trapezium rule is h divided by 2 times the first plus the last plus 2 lots of everything in between. So t equals 0 is our first point, so that is at 0. Our last point, t equals 8, the is 30, and then it's 2 lots of the ones in between, so there are 3 of those. So at 2 it is at 14, at 4 it is at 29, and at 6 it is at 26. And then remember, h represents what these are going up in, so this is 2 divided by 2, so that will be 1 in the end. So the 2 divided by 2 is 1, and then we have 30 plus 2 lots of that bracket, so 14 plus 29 plus 26, so it's 2 lots of 69, so then we can times that by 2, add on the 30, and we find the answer is 168. Now an estimate for the distance travelled, the trapezium rule actually finds the distance on a velocity time graph, so it is 168, but this is in meters because our velocity was given in meters. So if I want to go from meters to kilometers, I need to divide that number by 1,000, as there are 1,000 meters in a kilometer, so that is 0.168 kilometers.